Right, today we're going to look at this Keithely 35617 EBS programmable dosimeter. Now it's also basically the same thing as a 617 electrometer. It's the same thing, but this is customised. This has got an extra piece in there and some extra connections on the back. And this needs some work because the caps are bad and that sort of stuff. So I have not really verified it works and that sort of stuff. I know it powers up, but because the caps are bad, I didn't want to do too much with it. So I haven't actually tested it out properly or anything like that. But this needs full recap. I've got some parts here. There's a bunch of caps in here. They're going in there. Well, not all of them, obviously, but a bunch of them. We'll see if it works in the end. I mean, I don't know if it works or not. I don't know if it's good or not, but say the 617 is the more commonly available unit. And this, that is actually a label over the top that's covering up something. So I think it's originally used to say 617, and they've put this label over the front to replace that because it's a factory upgrade. Now I'll show you the back. Now the original 617 doesn't have this thing here, so that's what makes it a little bit different. Bias output up to 300 volts. So yeah, I think a lot of this other stuff's basically the same. I have no experience with these things, so I've got no idea, but the model number on the back here also says 356. It used to say 17 as well, but when I purchased thing, that label was actually intact on the images online from eBay, and it got torn sometime between then and me getting it. So yeah, it was actually saying the full model number as it does in the front, but it is basically a 617, but it's got this extra thing, which is interesting because it's adjustable, positive, negative, and percentages as well. And so it's got a circuit board in there for this. Now I did actually pull this apart previously and show people inside, maybe in a live stream maybe. Let's open this thing up and work on it. Now this is precision equipment, so I will actually have to put gloves on at some point. Not yet, but soon. Fire that screw in, nothing to go in that far. Yeah, see, it's just screwing out. That's fine. This has got one screw missing. I can probably replace this. I expect I've got some screws I can use to replace that, but I'm going to worry about it right now. Top cover off. Now the original 617 doesn't have this handle on it. It's got a sticker on the front which gives you like basic operating instructions. And here's the inside. So this is the EBS piece. This is the extra bit they've added in here. And that board there piggybacks off this board down here. So it's quite interesting that they've done this design. And looking around, which is why I haven't powered it up for very long, I think I did it very briefly. That cap's bulging, that one's bulging, that's actually gassed out. That one's bulging slightly, that's bulging, those are okay, those are okay. But the fact there's like a bunch of caps which are bulging, not a good sign. Now I did already change the voltage selection over here to 240 volt because I wanted to power it up and just do some kind of testing on it, see if it lit up or anything, you know. And it's verified that when I received it, it was not completely screwed, but that seems okay. So in here's all the precision stuff, and the power supply here is on the same board as the precision stuff, interestingly. So we've got to completely strip it down, take all the boards out, completely strip it, fully recap it, see what problems occur once it's recapped. I'll probably have to recalibrate it somehow too, you know, do an adjustment on it and see what that's like. This is going to be quite a long process, I think. It's not too bad. It's just that this is precision under here. So let's actually pull this off. Little flying lead here. Long screws. And it says Cal 1065 Inspect 1300. I guess that's from factory when I did the original configuration of it. So the screws are lost here, let's put it there. And there you go, there's the precision stuff. Now I looked at this before and I was a bit confused by one thing. This capacitor right here. Now in all the 617s and stuff I've seen online, that's a poly cap. A polyester like this one here, same as that, but slightly different value. This isn't a polyester, this looks an awful lot like a tantalum, which is interesting because I don't think it's supposed to be polarised. Now I'd actually try and find the correct capacitor for this. Couldn't find it. I'm trying to find polyester caps. Trying to find them, I don't know. I just couldn't find one. Because I was thinking I could get a cap and potentially replace it if it is indeed the wrong one. because it just looks wrong. You know, it just doesn't look like it's supposed to be there. I don't know, is the solder even different? I'm not sure. Let's have a look. I mean, does that solder there look different to the solder here? I think it does, eh? It looks a bit shinier. So that probably isn't original. Bit hard to tell. I mean, it may be original. I mean, it may be a factory modification. They've decided to use that cap instead. You know, but I'm just not sure it's right. Maybe if you've got a 617 or one of these EBS models, the 35617, let me know whether that is the same as your unit. Because if there's other units out there with the same cap in it, I'll probably want to leave it alone. If someone's changed it incorrectly, I need to fix that. Anyway, all this stuff in here, this is all precision. I can't touch this. High leakage issues. You've got a film resistor there. There's a big resistor. That's 250 meg. I think that's 100,000 meg. Yeah, I don't know. That's what it looks like anyway. Could be wrong. Maybe it's 100 meg. I don't know. Big resistors. So, no touchy. Right, got the gloves on. Feel a bit more comfortable taking this board out. Got a connector there. Got to take this off. Hopefully it's polarised, so I don't screw that up when we put it back on. It is. Going to go one way. There's also going to be interconnects between this board and the one underneath. Somehow, I'm not quite sure how that's done yet. We'll find that out. So there's screw there, screw there. Just get some tweezers to hook these out. There's it in free now. It is. Okay, it's the whole frame free. Now there is a ribbon cable running down here. I've also got this cable running out to the tray. So the trace cable, unplug that. Ribbon cable, that plugs into the main board just down there. Perfect. So I think that's that one out. Yep. That's that board out. So I actually need the gloves for handling this board. So I might do this board first, get it done, and then move down to these other boards. Well, I don't need to wear the gloves for those ones. So let's pull this one apart. That standoff, that's what's holding it. So I'll take that standoff out, and then I'll recap this board and come back to the rest of it. If you like my repair videos or any electronics repair videos, this kind of thing, and you're not already subscribed to the channel, make sure you subscribe. There's a link down the bottom there somewhere. Make sure you do that. There we go. And it comes out the tray. No signs of any rework or anything. That's good. It looks spotless. Got to recap it. Now I want to try and avoid messing with this area here for obvious reasons. One of the things these can have is bad relays, because there's little reed relays in here. This can fail and get dirty and get a bit intermittent or have issues with getting good connections. Because this is precision stuff, it's like, it matters. So I've actually bought some relays which are in here. It's the actual reed itself, not the whole coil. So if there are issues with any of these, I could potentially replace them. I'm really hoping I don't have to go there though. Hoping they just work, but you never quite know, dear. So yeah, there's a few things that can go wrong with this particular unit, and that's one of the things. So I'll pull these caps out. I will show you some, I suppose. I won't show you the whole process because it gets a bit boring with someone taking dozens of caps out, but I'll show you a couple of them and we'll go from there. Right, the first caps I'm going to do are these two here. These two caps are 1000 microfarad 16 volt. I've got some 25 volt ones. I'd actually buy some 35 volts, but I realised I've got some 25 volt ones, which are also 105 degree rated Nigicons, so I'm going to use those. They're also physically closer to the originals, so I'll do that. Now I'm going to put some fresh solder on first to make it easier to desolder. It's always helpful. I should also get my tractor fan going too for this, but that's a bit noisy. I should absolutely do that. I'll do that in a minute. I'll get this out first. Now these are the way you can use the desoldering gun and like get these out, which I will be doing. But you can also just do what I'm doing now and just heat them and walk them out one side at a time, and then use a desoldering gun to clear the holes out. Just like that. So let me get my film extractor going. I don't normally like to have this running when I'm doing videos, but I'm going to be doing a bit of soldering, so I need to get rid of the smoke. Plus I've got air conditioning on and the room is closed up, so I need to make sure I don't end up smoking myself out. And as always, check polarity. So easy to get the polarity wrong. Anyway. So one leg at a time, and I'll bed them down. Then the other one. So the smoke going up there means I'm not breathing it in. Okay. And I'll go around and clean the flux up afterwards once I've finished doing everything. Rather than doing it as I go. Just easier that way. So that's the first two caps done. I'll just repeat that process for the rest of them. You don't need to see that, so I'll go back when I've done it. So I'm in the process of replacing these. You can see I've got a bunch of them done already. I've only got like 4 left to do. So just taking these ones here out, 450 volt, 10 microfarad. This one's been leaking. And this is why you do it, even though like this one on the top, that's very slightly bulged. But even the other one which wasn't bulged, it's still been leaking. You can see it. So yeah, this is why you replace caps even if they look okay in older gear, because you never quite know what you're going to find. So I'm really not liking here. Look at how small that clearance is between that pad and that track going past it. It's really small. This is 450 volt rated caps, right? So this is high voltage going past here. So that gap isn't great. So basically, that polarity is across this capacitor here. So whatever the voltage is across that cap is what's across that tiny little gap there. I really don't like that. I'm not quite sure what they're thinking when they laid this board up, but that was not good. And this one here, you can see I've been cleaning it up, but it looks like the board's been probably arcing underneath. Where it's had that leakage, it's been arcing across underneath the board. So that's really not good as well. So I've been scratching around here with a scalpel. What I've decided to do, because I really don't like that clearance, because that is absolutely tiny. And as you can see, the track comes down here, so it's across that capacitor. So as I said, that's like not good enough. So I've actually cut the track these two spots here, and I'm going to put a jumper across here to bypass that piece of track to get it so there's a clearance here. I think there's a mistake for manufacturing, but you know, the design stage. Now obviously this is all burnt and stuff over here. I've been scratching this. I've got most of it away. You can see there's still a burnt bit just there. See that? So I'm going to basically dig this out so there's no carbon left, and then I can I'm going to tin all this, tin all these traces, and basically the trace is still intact. There's a bit there which is I'm not sure about. It's like almost like there's a break there, but once I tin it, it'll probably be fine. Yeah, so we'll see how we go with that. But there's still a bit burnt there. I want to get all this burnt out. Any carbonised PCB is not good, so all that's got to go. I'll scrape the surface here, I think that's alright, but just a little bit left there. It's obviously been arcing between here. So, yeah. Fixable, not a big deal. I can always drill a hole in the board, doesn't actually matter. But, yeah. Bit disappointing, but these things happen, older gear. Alright, I've put some solder mask on that. I'm happy enough with it. We'll see, I don't know. So, I'm going to put these two big caps back in again, add a jumper wire to bypass that track which I cut out because I didn't like that clearance. I'll put these other two in and I can put this board back together. So that's those installed. There's a jumper hooked up on there. It's got some clearances there, both from the board and from that capacitor. So that's better than it was from factory. Now I'll put these last two caps in, clean it all up. Once that board done, cleaned up, rebuilt, so hopefully that's good. I really hope so. But at least this one's fully capped now. That's good. So you can move on to the next boards. No more gloves. I can relax a bit more about that now. What I want to do first though, before we go into those boards, is look at the capacitors that we took out and see what kind of condition they're all in. So I'll stick this on the Sencore. You can see bulging in the bottom of this one as well. Top's not bulging, bottom is bulging. There you go, there's a clue there. Right. Top is not bulged, bottom is bulged. This goes to prove you can't trust the bulging. Bulging is if you see a bulge, it's definitely gone. But just because it's flat doesn't mean it's not. I'll get the LC102 fired up, get it all zero and everything, and we'll chuck these on the LC102 and see what these come out as. So first I'm going to do these 25 volt 10 microfarad caps. I've got it preset. Got the first one hooked up, obviously I've zeroed it all already. I've got my lamp here facing upwards onto the screen. That seems to help the illumination so you can actually see the thing. Problem is LCDs are really hard to read. Actually, let's get a bit closer. Now I've shown you that. Let's check ESR first. Says it's good, 1.74 ohms. Okay. Value 8.65. It's down a bit. I haven't set any percentages up actually. Let's just go. Let's go 20% and 20% minus. That's fair, I suppose. Right, so value again, and it's going to say good. It's just in. Right, leakage. 11 microamps dropping. Yeah, okay, that one's looking alright. Now I've got a few of these to check, so we'll check them all. Then I'll change to a different capacitor. No. This one appears to be, yeah, if I have no leads connected. Okay, so let's just try this again. This one might be really bad. Yeah. Leakage. 30 microamps. 19 microamps. It's coming down. It says leakage is okay, but it's much higher than the other one. And it can't get ESR. That one, it can't even read it properly. Next one. So these are all the same values, all 10 microfarad, 25 volt. So that one's obviously bad. Next one. 1.9 ohms, yeah, okay. 8 microfarad, barely. I mean, it's still 20% down. And leakage, okay, so that one's not too bad. I know this probably isn't the most exciting thing, but maybe you're interested to see if these are all bad or not. That one's bad, I think. Yeah, that's dead. That one's dead. I'm going to try the next one. That's dead. So that's 2 bad caps out of 4 so far. This one I didn't actually have the right version, so I had to substitute. So this one here, it's a 1500 25 volt. I had to put in a 2200 because I couldn't get that value for some reason. Anyway, 1500 microfarad. We'll check this one out. Yes, sir. Good. Or is it shorted? No, yeah, it's less than 1000. And leakage, 3 milliamps, 1 milliamp. It's dropping. I don't trust that one either. I think that one's probably bad. It seemed to give me some interesting readings. Let's do some 16 volt caps. Got to do 1000 first. Right, ESR. Good. A little bit low. Leakage is okay, apparently. Okay, next one. This very least is good for comparison. Again, reading a bit low. And leakage is coming down. It reckons it's okay. It still seemed to be a little bit slow to come down. Don't have to do this really, but I think it's a good thing to do. Bad, 21 ohms. Yep, that's bad as well. 50 microfarad, yes. So yep, that was dead, even though it looks fine. No obvious reasons for it to be dead, but it is dead. Okay, next one. And these are 470s as well. Yes, sir. Good. Value. Ooh, bad. Leakage. Yeah, I reckon it's okay, but value was way off. Another one the same. Yes, good. Value bad. Leakage okay. Yep, not a bad cap. So we've got about half of them so far, no good. 350 volts. I might let go of the probes for this one. 350 volt. And the value is 4.7 microfarad. Okay, ESR. Error, can't read it. Value. Bad. Leakage. Get in there. Bad. Okay, this one is one which vented. So definitely a bad cap. Another one next to it. This is the other one which is the same. Exactly the same. ESR, okay. Value, a little bit on the high side, but it's okay. And leakage. Thinks it's bad. It did seem to take a little while to come down. Might be slightly bent on the bottom there, so I think it could be bulged slightly. And the next one's 450 volt, 10 microfarad. Now, don't forget, both of these are leaked, so it could be interesting to see what we get on these. 450 volt, 10 microfarad. Right, ESR, 56 ohms. This one's only got a very slight leak on the bottom. Right, it's this one only just started to leak, so this was the better of the two. And the top's, I don't know, I can't really see it, can you? But it's got maybe a very slight bulge, very slightly bulged. It's only just showing signs now of bulging, and it's been leaking as well. Right, value 11 microfarad. Value is actually good. Leakage. Bad, it reckons. Not surprising. Let discharge before I let go of it. Alright. And last one. And this one has been leaking a lot. That's did all that damage on the board. That are arcing underneath. No bulge though, but leaked underneath. ESR, bad. Unsurprising. Value is good. Goes to show you can't trust value all the time. And leakage is looking higher than the other one, but coming down quicker. This one might pass leakage test. Maybe. No, not quite. So of all those capacitors, about half of them are bad. This is why I change them, even if they look okay sometimes. Alright, now we can take the rest of this thing apart. I'm going to take this board out first. This Dosimeter board, I suppose. It plugs in as well. It's got the same cable and the cable connections here, like actual colours as well, as the one which went down to this board. So it's almost like it's a pass-through. So maybe the original board just went straight to that plug, and this is passing through and coming up here, and it's piggybacking off that supply. I wonder if that's actually what it's doing. Certainly could be. So there's a 3-pin plug there, which is keyed as well. Can't really mess that up. Just take this board out. I think it might actually be attached to the bottom board, but I'm going to take it off anyway. I need to recap it. And we'll go from there. So there's only one capacitor on it, so it's not too hard to do. It's warned a bit high voltage because this can do like 300 volts or something. Does it say what it is on the output? Yeah, output 400 volts DC. That's what the little module there does. So yeah, watch out for that if you power this thing up. The high voltage level means it. Nothing underneath. Yep, cool. So that's that. And as I expected, yes, it does indeed just piggyback through. So again, factory add-on. Information about it there. Get the light on it right. Keithley R&D 37289C revision A. Yeah, okay. 91. Yeah, 13th for the 2nd, 91. Design date. Okay. Sort of trace layout too. Yeah, I don't know, I say it's just a factory add-on. One capacitor change, so we'll get onto that. And that goes down to the bottom board, which thankfully the bottom board doesn't have many capacitors in there. So we got 5 big ones. And I was looking to see if I could see any small ones, and there's one there. So it looks like I've only got 6 capacitors changed on the main board, which is great because that won't take very long. Could still be capacitors on the front panel. We'd have to look for that as well, see if there's anything there. There could be. So what I think I'll do is take this board out now. I'm not quite sure how hard it's going to actually be to do it. So attach the GPIB. I've had bad experience with GPIB connectors on these things before. I actually broke a stud off. I've still got it sitting here. Here it is here. I've got to find a replacement for one of these things. And there's the rest of it. If you know where I can get these, that'd be nice. It'd be nice to have some spares in case I break another one. Anyway, but that's what's holding this in, so I might need to be careful about reassembling that part. The rest of it plugs in. There's a connector there, and there's a connector there. So here you go. Let's get a close shot of those so I don't mess those up. Red is on this side, on both of those. So those could just be unplugged. And this one is got a connector as well, and it's red towards the centre. It does actually have low. This has got a marking for low and TV, VHVL. So it might actually be kind of showing the markings for which way around to go. This one doesn't seem to have anything. So I'm hoping that means it's easy enough to just unplug the back panel and just lift it off. Front panel is one of these connectors. Careful with them. They're good, but you have to be careful not to bend or break the pins off. I need to actually find some of these connectors. I don't have any of these like dip plugs. I don't think I've got any of them. I think I did try and find them at one point. I couldn't find them. So it's ribbon to wide. I think it's probably 24 pin or something, that one. But I would like to find like a selection of those, so I've got some spares. Because I broke them on once before and it was a mission. I had to manually solder it all together and fix it. Yeah, that's annoying. Just using standoffs everywhere. So we'll undo those. So we've got 5 standoffs on one screw. Chuck these over here. I'm sure I can figure out which screws go where in the end. I hope so. Like I said, I'll probably have to take the front panel apart as well and see what that one's got. This standoff was actually a little bit loose when I went to go and move it before. It might have come loose when I was undoing the screw, so there's another one there. They're not very tight. These standoffs you have to be careful with anyway, because especially aluminium ones, these are aluminium. They can cause problems. Because you can snap them off. If you try and over tighten them, they'll just snap. Then of course you've got to find another one which fits. And that as well. Let's unplug this connector. Hopefully without damaging anything. Try and do it really carefully. Can't really grab hold of that side. I don't think. Maybe I can get in there. Okay, that's it, it's out. Alright, that wasn't too bad. Okay, let's lift this board out now, hopefully. It might be stuck on the standoffs on the actual post. I've had that before on the 220 when I was working on that one. Okay, it's lifting. Why doesn't it want to pull out? There we go. Right, that's that. There's a lot of weight to this, so I'm trying to support it carefully. And then we'll do the front panel part as well before we put it back together. Right, that all done. That cap was surprisingly hard to get out. I think I might have bent it over a lot or something, I'm not sure, but I had trouble getting that one out. Anyway, it's done. Back onto that board. And now I'm looking at this board properly, I can actually see there's 1, 2, 3 small caps. For some reason I only saw one before, I don't know why, I guess I wasn't looking very well. Anyway, there's definitely 3 small caps and 5 big ones, so 8 caps to do. Yeah, not too bad. Right, so that board there, fully recapped. I almost missed one. There's one over here. Small capacitor. Another 10 microfarad, 25 volt. So, right there. Almost missed it. Even though I put one right next to it. That was the last cap I did. That one actually had leaked very slightly. It's just starting to leak. This just signs it on the board. I can't see anything on the actual capacitor though. That's interesting. But it's a 4716 volt. So, I don't know, I can't see anything on the actual cap, but I can see some witness marks on the actual pad that the solder mask was starting to go. So, it's only just started to fail, I think. So I think we've been a bit close with some of these caps potentially being disastrous, especially on that big board over there. One thing I need to do yet is check the front panel in case the capacitors on there. But before I do that, I'm going to test these caps and see if these caps are measuring, interestingly, with the Sencore, and then I'll do the front panel. Well, I've got it preset, so the first one I'm going to do is a 47 microfarad 160 volt. The bottom of this cap is slightly bulging, so we'll see what we get. ESR measures good. Value is bad. Leakage is pretty high. I think it's going to fail. Yep, 2 milliamps leakage. That cap is definitely gone. And that's one of these ones. Another one here, exactly the same. This one slightly less bulged, if it's bulged at all. Good ESR. Value's okay because it's supposed to be 47. It's slightly low. Leakage 10 milliamps. And down to the microamps. So this one's still testing okay, but I wouldn't trust it because its partner, these two are used as a push-pull, like positive negative supply sort of thing. These two are used as positive negative supply in the same situation. So if one's gone, the other one's going to be far. No, I'm not going to be far behind it. So this one's going to be 35 volts, and this is a 680 microfarad. I've got 2 of those. 680. Right. ESR says good. Value reading a little bit low, but okay. Leakage looking alright. Start off high, then drop down quite quickly, which is promising. Anyway, like I said, replace them anyway, doesn't matter. Its partner, exactly the same. ESR good. Value good. Leakage initially higher, taking longer to drop down, but okay. So this one's not as good as the first one. The first one was slightly better. So anyway, that's that. 25 volts the next one I'm going to do. And these are 10 microfarad. Got 4 of these to do. I know this isn't very exciting, but it's one of these things we've got to do. Some people might find it interesting, I don't know. ESR is good. Value good. And leakage good. So I've had one of these before which wasn't good, so I'll be surprised if one of these is actually okay. So far I've tested 5 caps, and of those only one's been good, really. I was at 2, maybe 2's been good, but it's not exactly a great record, is it? That's good. 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 Something's actually right. So these smaller ones are actually doing okay so far. We did find one bad one before, though, didn't we? Good. Bit low in value. Leakage is okay. Good. Bad value. Here we go, found a bad one. Leakage good. But the value was bad. So yeah, did find one bad one. So what's that? 4 bad, 4 good. 50% so far. Right, next one here is going to be a 4100 16 volt. So 16 volt. And 4700. Yes, sir. Good. Value. Oh, that's down by 1000. Sort of. Yeah, it's not sure it's good or bad. Yeah. It's on that borderline. Leakage. Okay. But yeah, the value is definitely down quite a lot on that one. And the last one of these. Yes, are good. Value the same as the other one, down by 1000. So probably not good. Leakage. Yeah, okay. Slightly slower than the other one, but still responds as being okay. Right, so yeah. Yeah, we call it 50-50, eh? So now we take the front panel apart because I want to see if there's any capacitors behind it. Might just be able to take those 2 screws out. Because I've done the 220 before, the Keithely 220, and I take all the buttons off. This has got different buttons on it. So I don't think this is going to be the same problem. I think I can probably just take out these top 2 screws and not take the whole panel off. And that might actually be all I need to do. See if that's all I need to do. Because it hooks in and isn't happy about levering out. Okay, so we'll look down there so I can see anything. I think the button caps might need to come off to get the board out because it hooks in. I'm going to have to unscrew it off the chassis. And this one doesn't unscrew very well because I've got the board cut out. It's not really very good. It doesn't really fit right. Here we go with this. Trying to get enough room to get this out. It's a bit of a design flaw. The 220 are the same design flaw. Basically rubs on the back of the front panel as you're trying to get the thing apart. Okay. Might be able to lift it off now. Here we go. There's only a tantalum in there. Just a tantalum. Okay, that's all good then. What I will do while I'm here is give it a bit of a clean, just to make sure it's all nice. Then I'll put it back together. Well, this is the process of reassembling it. Got it most of the way there now. Just got to put this last board in, and then we'll be able to try it. So yeah, it's going to be interesting to see if it actually ends up being okay or not. I really hope so it is, but we just don't know, do you? Especially after a major rebuild like this. Major refurb, you never quite know what you're going to get. Push that plug on, make sure I'm not off to one side. I think it's alright. We'll try and sort of flip this around here. Try not to touch anything important. Hopefully it all fits right. Okay, plugs in there. Plug this in. Come on, there you go. Come on, plug on. Okay, I think that's probably it. Hope so. Goes over there. I'll try and get everything lined up again. Going in. There it is. Not sure this is sitting right. Not convinced it's sitting correctly. No, it wasn't sitting right. It's sitting slightly forward. So I think the trick to doing this is to actually get one of these screws in first, and then get them lined up, and then put these ones in. That way it all lines up to the posts, because these ones are easy to see. You can just see where you're going. These ones obviously you can't see anything. So you're still not quite right there. It's not quite going to the post on this one. The post might be slightly out. Oh, this is going to be a pain, isn't it? Last screw. It's always the last one. But these aren't even tight yet, so the whole thing's moving around. Alright. So I should be able to get this in. But when I put that standoff in, it looked like it was slightly wonky. Just going to go in or not? No, got to take it back out again. Well, I got it back together. Basically, just redid that post, and it's still slightly off. I don't know whether it's the casing's a bit off or something. I don't know, but I found that if I put that screw in first, I could kind of manipulate it and get the other ones in. So we're good again. Let's put the top panel back on again. Oh, should we wait for magic smoke first? I think we will. Now I still need to go and do something. Got to go and get the shopping out the car for the wife, and I'll come back and we'll test it. Right, moment of truth. I've plugged the power cord in. Switch is off. Turn this on. You have to watch over here, see what's going on as well. Zoom me very slightly more maybe. Right, turn the power on. Watch for magic smoke. 11 watts. Seems fairly high. Still less than 100 milliamps though, so yeah, it's probably alright. Anyway, it's booted. Nothing's exploded yet. The power's looking fairly stable. It's not like it's increasing or decreasing or anything like that, which would show some kind of issue. So that's looking promising. You know, it's dropping down very slightly, but that's fairly normal. Put capacitors in, they've got a bit of reforming going on, and it is normal to see them dropping very slightly. So I'm not too worried about a slight decrease there. But it's looking alright. Okay, well it's looking promising, no smoke. So I might actually put the cover on. Maybe. Yeah, I'll put the cover on in case I touch something and do something silly. Let's be sensible, shall we? It's got a triax cable here out. This is a 2-lug triax of bananas. It's a decent quality cable. It's not like the highest quality, it's one of these like aftermarket kind of cheaper ones you can get, but they still seem fine. Right, plug this in the back here. Hopefully it's good connections. I'm going to plug this into something and we'll see what we get. Turn the power back on again. And we'll check some voltages. I don't remember what this thing can actually measure. I will have to look into that. I don't actually remember. I've forgotten. I should find out before I like over voltage or something. Ranges. Millivolts. So millivolts right down here. Volts. I don't know, maybe it's 100 volts max, maybe. I'm not going to be going anywhere near that, so I should be fine. I'll get something to plug into this. Well, I've plugged the PDVS2 Mini in. This cable's a bit in the way. Currently up in 0 volts. Sort of have a look through these. See if there's anything showing up. If I do 1 volt. See nothing there. On voltage we're seeing 0.2 volts. So that's a bit concerning because that isn't right. May have more to fix yet, it seems. Just checking the triax. Had issues with triax cables before. It does seem to be jumping around with that movement. I don't actually know how to use this either, which probably doesn't help. I've only got the output here, I've got the current source, which I'm not using. I'm not using the current source on it. I'm not configured that. Zero check is enabled. It shows up as being on. Can't seem to get that to turn off. Don't know how to get that to turn off. I don't know. It doesn't appear to be doing what I expect it to be doing. I don't trust a triax cable though. I've had problems with those things. Bad connections. I found it on the 220 when I did that one. I'm not confident. It could even be relays. I'm not sure how to get the zero check turned off. Do you think I have to read the manual? I've been trying different things with this and I can't get any real life out of it. I mean, it's doing a little bit of something. There's something there. So I sort of come back and look at something on this, thinking I'm missing something here. This zero check is always on, alright? And I was sort of thinking, what's going on? I mean, I should be able to push that button and have it turn off. So I've been messing with this button now. And now it actually turns on and off. I think we've got a dodgy switch there. If I wobble it around, it sort of comes on and off a little bit. So I think we've got a bad button. So with zero check on, we're not going to get anything because it's kind of not working. Actually, now it is working, even though I've got zero check on. Go figure. I don't know what's going on with this, but do 1 volt now. We've got 1 volt, and like I can go up to like 10 volts. It's looking really good. So it's actually working now. So I think there was something issue with this zero check thing playing up. So I'm just going to reboot it now, and we'll just try it again. But I think all I've really got to do is go, maybe I have to pull it apart again, clean all these switches up, just to make sure they're all behaving, because I don't think that one's working properly. Yeah, I mean, let's boot it up into that. Zero check's on. If I do 1 volt, there you go, you're getting exactly the same thing we're getting before. Turn it back off again, try and get that turned off. Now it's actually turning off. Before I was pushing the button, nothing was happening. Thinking, oh, something's wrong. Anyway, 1 volt, there we go. Yeah, so that is actually working. So no, it isn't broken, and it's actually working. So if I do like 1 millivolt, there we go. Next one down, yep. Next one down, yep. You can see that changing. That's the last range, yeah. So that's actually working. So all it is that button there, although now it's behaving a bit better, needs a clean. So winner, it actually works. So there I was thinking I'd have to do a part 2 video. Not so much. Oh, I'll give it a clean. You don't need to see that. Well, do a bit of testing on these things. So I'm outputting 1 nanoamp and on my 220, and it's actually working fine. Let's look how close that is. That's really good. So obviously there's going to be a bit of error on this as well. So that's actually looking excellent. Now I'm just using some triax bananas, and I've got this cable joining together, so I can do that because that's what I've got. You can see it changing while I touch the cables and that sort of stuff, just leakage and introducing noise, or triboelectric effects and moving the cables around, that kind of thing. So, you know, you have to give it time to settle each time you move something. But it's looking really good. So if I do like 0.1, so get 100 picoamps, and yeah, we can actually get in there. Again, got to give it time to settle down and get there. But yeah, it's looking pretty good. It seems to be working fine. Now, when it gets down to about, well, less than that, let's go 0.05. We get right down the bottom end here, it starts to get a bit wacky and go off. I'm not quite sure which device is causing the problem. That's looking okay there. But no, so I try and do 10, it just can't do it properly. So 30 is looking good. Yeah, I'll just do it. '20 is looking close. 10 is actually doing okay this time. It's not always doing okay. I don't know if it's relays in here or what. Let's just try changing ranges manually. Yeah, seems alright. When you get right down to this low level, it's where it really starts to struggle. So, I mean, this can do it. Whether this is doing it, I'm not so sure. So I could do a zero check on that. But I don't think it's going to help much. We'll see. Yeah, it's getting this right down the bottom here. I think it's probably this is running out of resolution to create that kind of accurate output. So yeah, I mean, it's working kind of okay. 5. I mean, it is definitely doing something, but now at the below 20 or so, it starts to get a bit So I think that's at the limits of what this can do, but this can still go further, so it's pretty good. Let's do 1 again. And 10. So 10 nanoamps, fine. Look at that. We're looking pretty good there. 100. Yep, it's looking good. Next range up. So microamps. Yep, it's looking really good there. I haven't tested this yet. Actually, I want to do that. I don't to do. I missed that one. Anyway, doesn't matter. Yeah, 0.1. Yep. Yep, milliamps slightly out there. 10 is looking good. I mean, expect a few counts. Well, I expect it to be out slightly. So the fact that I haven't done anything to calibrate this, just recapped it, cleaned that switch up, and well, cleaned all the switches actually in the end, and that's working. So, and 100, overload, 50. Not sure what the maximum can go on this thing. 20, 20. Yeah, 20 is the maximum. Okay, so that's fine. But it's looking really good. 5, yeah. So obviously this is really meant for doing currents. Voltages are a bit sort of, you know. Yeah, there's 10 volts. That's what output on this thing. Roughly, it's roughly 10 volts. It's not precise, but I mean, obviously it's only 4.5 digits. It's not particularly wonderful for a multimeter, for a voltmeter. It's not particularly great for that. But current is where this thing really shines. So yeah, that's good. I haven't tried resistances yet. I should try that. Well, doing resistance using this decade box here. I'm not quite sure what ranges it's got. So this is the lowest it can do is kilo ohms. Yeah, that seems like it's working. So lowest range is kilo ohms. I was hoping we could do lower than that. So I suppose for resistance it's also kind of, unless you can do high resistance, I don't actually remember what I can do. It's 1 mega ohm. Yeah. So I'm not quite sure how high this can go in resistance. I might have to go and check the specs on that. But this box can't go that high. Might have to look at that in more detail. So I'm just reading specifications now, and obviously I looked at these originally before I purchased this thing. But volts ranges is 200 millivolt range minimum with a 10 microvolt resolution, 200 volts maximum with a 10 millivolts resolution. Amps are 2 picoamp range minimum with a 100 attoamp resolution. And the maximum is 20 milliamps with a 1 microamp resolution, as we already saw. There's coulombs, which is something I've got no experience or knowledge of. And it's got 200 picocoulombs and 10 femtocoulomb resolution, and 20 nanocoulomb and 1 picocoulomb resolution. Ohms is a 2K range, which is 100 milliohms, as we saw. And the highest range is 200 gigohms with a 10 megaohm resolution. So this can do really high resistances. So that's the benefit of this one. So it's pretty good. Be useful for something, I'm sure. That's why I got it. And I'm really pleased it actually works. So we're going over here, push shift and ohms. I've got this extra one that says V over I. It's ranging through all the ranges. So you can see all the other ranges. Let's go up here, give it something to actually look at. But you saw tera ohm just then, so that's a good going range right now. There's tera ohms. Look at that, tera ohms, amazing. So something about this extra range, I'm not quite sure what that one is. I don't know how to use this thing properly yet, but anyway, you can see I'm doing 1 meg ohm, and that's reading fine. Just capacity between those two, but you always get some ranging things. It's quite normal. But yeah, look at that, it's looking really good. Even up here, it's working fine. Yeah, obviously that's going to be out of range. But yeah, brilliant. Now, I haven't checked the output yet, I should look at that. So now we actually have the voltage source on here, alright? Let's see if this works, I haven't tried this yet. So I've got it hooked up. I'll just change the display so you can see the source. And we're getting minus 0.1, so it's got a slightly negative 0 point. I don't know if that's something I can adjust or not. Anyway, let's go up by that. Okay. It goes up by that much. Right, so steps and 5s. Okay, let's turn the output on. Stayed the same, 0.1 or minus 0.1. Let's go up by 5. Okay, let's go up by, now it says 0.1. 0.1 is now, yeah, okay, so the bottom end again is not wonderful. Okay, this might need adjusting. So 1 is 0.06 high, and it's, you know, six counts on this thing. This might need adjusting. 2 is 7 counts out. Alright. Seven counts out, 3 volts. Okay, let's just see how this goes. Has acceleration as well. 5 volts, 7 counts out. I think it goes up to 100 volts. So, you know, 10.8, 7 counts out. So 20 volts. By the way, it's got acceleration built in. Trying to preempt where it's going to stop is the funny thing. Anyway, 20 volts, looking pretty good. Still some counts out there. So effectively 6 counts out. So it seems consistent. It's got that slight offset there. But interesting, the 0 was below 0, and the other ones are above. So it's sort of like, okay, I don't know if it's a calibration with 0 or not. Let's want to do 60. Nice, around 60. 60 is 14 counts up. Alright. But at least the voltage source is actually working. Let's do 81. 16, 15 counts out. And 102, 15 counts out. So it's consistently high, apart from the 0 end. So let's see how quickly it accelerates as you just goes through the range. Oh, look at that, it gets quicker and quicker and quicker. That's nice. Nice design. Better than some modern equipment, to be honest. Right, so we can do negatives as well. So negative 0.5. So we can probably go down negative 100 as well. So maybe we'll try that. Maybe there's like a 0 point setting, and that's what we need to change, as well as a range setting. So let's do like, let's do 54. That's 13 counts low. So it looks like the 0 point, and then the overall range might need adjusting. I don't have to adjustments for this, I have to look. 70, 10 counts low. $100, 7 counts low. Okay. And 102.35 minimum. Okay. Let's do 102. 6 counts low. So yeah, I mean, it's actually looking pretty good. It's consistent and linear, at least. So that's good. And it's actually working, so I'm really pleased about this. It's actually working. I might look at the information manual about adjusting this output. I would like to have it accurate if I can. If I turn it off from there, what happens? Yeah, it does go to 0. So yeah, trying to get this to actually be 0, I think would be something I'd like to do. So the voltage adjustment for this voltage source is actually a closed case adjustment. Now obviously a lot of the actual calibrations as well, also closed cases can do them from the front panel. Right, it's actually a calibration on the screen. So that's also done, but this is actually done with a trimmer because it's separate to the main electrometer thing. And basically there's a little trimmer just here, right there. And so you set it to 100 volts and you can then adjust what you want. Right, so the maximum here, 105, it's fully clockwise, and fully anti-clockwise, 98. So it is indeed biased upwards. Anyway, we'll try and get this to 100 exactly, and then we'll see what the zeroing is. Now there is a factory selected resistor from what I can see on the circuit diagram. Oh, it's jumped a bit there. And that may be setting the 0 point. Anyway, happy with that. Oh no, I'm not happy with that. Let's go a slight touch clockwise, just the slightest little bit. Oh look, now it's jumped. Let's give this a trimmer, a bit of a wiggle around the area. Maybe it's a bit dirty just there. Right. Definitely jumps. Yeah, it's a slightest little touch there, it jumps. Anyway, so I'll see what the negative is like. I'll leave it there. Let's go negative and see what that does. So going back to 0, it's still saying minus 0.1, and there's negative 100. I think I'm happy enough with that. Let's try a different voltage just to be sure. Something in the middle of the range is okay. Check linearity out. Let's do about 50 or something. Yeah, 60. No, 59.5. That's 5 counts up. Don't forget it's got that 0.1 offset, so that's probably affecting this slightly. Yeah. Let's try and do like 10 volts. Minus 10, there's that 0.1 offset. So that's showing up at these levels. Let's do plus 10. There we go. It's also got an offset. So it's not perfect, but I think it's good enough. So yeah, I'm very happy with that. It works well. I will obviously need to check higher resistances to make sure they were behaving. I do actually have some fixed resistors here somewhere which I purchased. I haven't used them yet. To do, like, I think they're like 1 gig ohm and stuff like that. I've got some resistors like that I can use, so I can check them with those. But I need to check all that stuff yet. But it's working. Recapping it, cleaning switches up. It's working. I'm happy. So this is a piece of test gear I can put on my arsenal of things to use in the future when I'm repairing other pieces of test gear, which is what I like to do. My favourite thing is to get a piece of broken test gear, fix them up, bring them back to working operation again, and have them here to help me fix other pieces of test gear, like I was using the Keithely 224 before, that current source, to check this thing. That's a piece of gear which I've did a big repair on. I did a lot of, I did like 3-part video, 4-part video on that one, can't remember now, fixing that one up, and that works perfectly now. So I'm really happy with that, and that allowed me to help fix this one, and so on. I'll probably use this for something else as well to help fix something else or verify something else or whatever. I mean, this is ancient test gear. This is from like the late 80s. 40-year-old test gear. It still works and it's still accurate, or at least accurate enough. I mean, this electrometer part is still accurate. Voltage source not perfect, but probably don't matter much. If you'd like to see me do more videos repairing test gear, I need money for that. So if you want to donate some money, You can use the things down below there, do a thanks, or you can become membership on YouTube. Ideally, there's a Patreon support link over there. Use that at the end of the video, or there's also down in the description. Use that because you get more benefits, like when I publish a video for this, I've included manuals with it on Patreon. Don't get that with YouTube. Catch you later. See you next one.